Okay, so find the equation of the normal to the curve with parametric equations x equals 1 minus cos 2t, y equals sine 2t, at the point P where t is equal to pi over 6. So this time we want the equation of the normal. Before we go about that, we've got to appreciate that because we've got differentiation to do here, we're going to enter values into cos and sine. We need to be in radian mode. Okay. So in order to do that, you press shift, set up, look down for number 2, the angle unit, and you change then to radian. So press 2, and you can see then on your calculator display, you've got that little R there to represent radian. We must have that, right, wherever we use calculus. In other words, if we differentiate or we integrate involving cos, sine, any trig function, it has to be in radian mode, okay? Otherwise, it's all going to go wrong. So, we'll differentiate dx dt. Well, 1 becomes 0. And if you remember, cos becomes minus sine. But because I've got a minus there already, that just becomes 2 minuses, which is a plus. So sine 2t. But then you've got to times it then by the derivative in there, because it's a function of a function. You times it by 2. So dx dt is 2 sine 2t. And I can flip that. And I get 1 over 2 sine 2t. Same situation here, dy dt. Sine becomes cos when I differentiate it, cos of 2t. Times then the derivative in there, which is 2. So I get 2 cos 2t. So using the chain rule, dy dx will be dy on top, right? Times then dx on bottom, so dt by dx. So dy dt is 2 cos 2t. And dt dx is 1 over 2 sine 2t. Now you'll notice here there's 2 on top, 2 on bottom, so they'll cancel. And we end up then with cos 2t times 1, which is cos 2t, over sine 2t. Now you might be tempted now to change this to be cot 2t, because cos over sine is cot, isn't it? But don't do that. Don't do it, because we are trying to find the gradient value, okay? We actually want the normal value, but in order to do that, we need to keep it in terms of cos and sine. Don't go changing into cot, because it's going to cause us problems. So we just need to appreciate that dy dx is equal to that. So what we can say then, at the parameter, at the point t equals to pi over 6, we can work out dy dx equal to cos, so sub it in, right? It'll be cos 2 times pi over 6, okay, all over sine times sine of 2 times pi over 6. So if I get my calculator, fraction button, cos 2 pi over 6, close that, all the way down, and sine 2 pi. Now, as I said, if you're not in radian mode, this won't work. So you've got to be in radian mode. So if I do that, I get this at root 3 over 3. So write it down like that. Don't try and press the SD and get all messy. Just write it like that. Now remember, this is the gradient of the tangent. We want the gradient of the normal. So you've got to do m1, m2 thing, yeah, equals to minus 1. So your m1 is root 3 upon 3. Your m2 then is what we want to figure out. So you can take the root 3 over the other side and divide. So if you do that, in fact, I mean, we know it's going to flip, yeah? The 3 is going to go on top, but you can check that on your calculator as well, because there's something nice that's going to happen now, because you've got 1 on top, and you've got a fraction here, root 3 upon 3, course that comes out just to be nicely then minus root 3, okay, because it rationalizes, and you get that. So there's the gradient of our normal. So we've got the gradient of the normal. We just need then to figure out what the x and y values are. So remember then x, going back to the equations at the start, 1 minus cos 2t, y is sine 2t, so you've got to sub in pi over 6 in this. So 1 minus cos of 2 times pi over 6, okay, and that will equal to a half, and then y will equal to sine of 2 pi over 6 that comes out to be root 3 over 2, okay. So the equation then of the normal well, using that formula, you've got root 3 over 2 here, you've got minus root 3 for the gradient, and you've got your x to be 1/2 there. Okay, so what we could do here, because we've got like a stray half here and a stray half there, let's just expand that bracket. So minus root 3 times x, okay, will be minus root 3x, and minus root 3 times minus half is plus root 3 over 2. And what we can do then is times through by 2. Okay, or actually, thinking of it, if I take the minus root 3 over 2 over, it becomes a plus root 3 over 2, and this is like a half of root 3, add a half of root 3, that just becomes a single root 3. You can check on your calculator if you want, but you've got half of root 3, and half of root 3 is this whole root 3. There's your answer there. You could even tidy that up and have root 3 then in a bracket, factorize in 1 minus x. You could write it like that, and there's our answer.